graphs of f of t is equal to the natural log of t plus 5, and h of t is equal to 2e to the t minus 1 are shown below. So this is f of t right over here. This is h of t right over here. Drag the variables to show which equations they must satisfy. There can be any number of variables per category, and some variables might not go in any category. So what are they talking about? Well, we have all of these variables here, and they want us to drag them into different categories. And if we look at the actual graph, we see that these variables correspond to either the t or the y coordinate for each of these points that they've picked out right over here. And so we need to figure out if you were to, for example, drag this into this box, that means you believe that 2e to the t sub 1 minus 1 is equal to the natural log of t sub 1 plus 5. That this variable, if you substitute it in for t, that is going to make this equation true. If, for example, you were to substitute this y1 in, that means that you think 2e to the y sub 1 minus 1 is equal to the natural log of y sub 1 plus 5. And so the three different buckets that they give us are essentially setting the two functions equally to each other, setting 2e to the t minus 1, which was h of t. So this is essentially setting h of t equaling 0, and this is f of t equaling 0. So let's take each of them in turn, and I copy and pasted this onto my scratch pad so that we can work through the math. So the first case that they had was setting these two things being equal to each other. So for what t's, or what can we substitute in for t, so that the natural log of t plus 5 is equal to 2e to the t minus 1. And that's another way of saying for what values of t is f of t, this is another way, for what values of t is f of t going to be equal to h of t. Well, two functions are equal to each other at a given t is if you put that t in, they both give you the same function value. They both give you, in this case, if we say y is equal to f of t and y is equal to h of t, they'll both give you the same y value. So if when you input some t in here into both of them, so you input the same t into both of them, and if you get the same output out of both of them, that would correspond to the same point. So we're essentially saying, where do these two functions intersect each other? And we see that they intersect each other in two places. There's this place over here, where the coordinate is t sub 5 comma y sub 5. So you input t sub 5, so this is t sub 5 right over here. You input t sub 5 into either function, and you're going to get y sub 5. Or another way of writing this is f is y sub 5 is equal to f of t sub 5, and y sub 5 is equal to h of t sub 5. You see that right over there. Take t sub 5, evaluate your function h, there you get to y sub 5. Evaluate your function f, there you get to y sub 5. Or you could say that f of t sub 5 is equal to h of t sub 5. And I'm just writing it in a million different ways, not a million different ways, but a lot of different ways, so that you get the idea. And this is the same thing as saying, of course, that the natural log of t sub 5 plus 1 is equal to 2e to the t sub 5 minus 1. So this is definitely going to be true if t is equal to t sub 5. So let me just make sure that let me write t sub 5 there. So t sub 5 definitely fits into this category. You put t sub 5 in there, this is going to be true. And then we have another point where these two functions intersect, right over here. If you input t sub 1 into either function, t sub 1, you get y sub 1. So once again, same exact logic, t sub 1, this is also going to be true if t is equal to t sub 1. So this is also going to be true for t sub 1. So that first category, we can put t sub 5 and t sub 1. So let me make sure you can see what I'm doing. So that first category, I could put t sub 1, and I could put t sub 5. Now the second category, the next category, we're saying when does 2e to the t power minus 1 equal 0? So let's give myself a little bit more real estate. So they're saying, let me draw a little line here because this is the next category. When does 2e to the t minus 1 equal 0? Which is another way of saying, when does h of t equal 0? And so if h of t is equal to 0, and if we're saying, if we're plotting the function 8y is equal to h of t, we're essentially, when does y equal h of t equal 0? Or another way of saying this, when does h of t intersect the horizontal axis? When is when is that graph not above or below it? Our y value here is 0. Well, h of t is the blue graph, and it intercepts the t-axis right over here. It intercepts the t-axis right over there. We see that h of t sub 3 is equal to y sub 3, which is equal to 0. Or actually, I could even write it this way. H of t sub 3 is equal to 2e to the t sub 3 minus 1. That's just from the definition of h of t. And that we know that that's going to be equal to y sub 3, which is equal to 0. Y sub 3 is clearly equal to 0. We're clearly intersecting the t-axis there. So t sub 3 would fall into that second bucket. And that's the only place where, on the graph of h of t, where it intersects the t-axis. So t sub 3 is the only variable I would throw into that bucket. So let's do that. So I would throw t sub 3 into this bucket. And then the last bucket, we're doing the same thing now for f of t. So f of t is the natural log of t plus 5. When does that intersect the t-axis? So this is f of t right over here. We clearly see right at this point, f of t sub 2 is equal to the natural log of t sub 2 plus 5, which is equal to y sub 2, which is equal to 0. So that last bucket, this thing, natural log of t plus 5 is equal to 0. This was that last bucket. This is going to be true for when t is equal to t sub 2. So we could throw t sub 2 in that last bucket. So let's do that. T sub 2 gets to go into that last bucket, and we are done. These other ones we are not going to use. I mean, the rest of them, these are the y values that the functions take on at those different points. And t sub 4 is kind of interesting. T sub 4 is actually clearly equal to 0, because that's when we intersect the y-axis. So that's, I guess, an interesting point, but not one of the points that would satisfy those buckets. And now we can check our answer, and we got it right.